first fun word for you today is what is an altitude? If you talk about the altitude of a plane, you're talking about the height off the ground. So that's altitude, A-L-T-I-T-U-D-E. This right here, BD, is the altitude. Okay, altitudes have to make a right angle. That's the important part. They make a right angle with the base. Same thing here. They make a right angle with the base. And when you have an altitude or it drops down a right angle or it drops down perpendicular, then you're going to have similar triangles, okay? So we've got some pieces here. We've done this before. Oh, let's see. In this picture, it would be BD corresponds to FH. Hopefully that makes sense. And that's equal to, you could do any side, but you could do like AB and EF. So I'll highlight those real quick. So here's the first ratio. And then the second will come from AB and EF. Okay. So an altitude, the key thing here is it is a height and it is perpendicular. And it creates similar stuff, okay? Similar pieces or proportional triangles, okay? The next thing is an angle bisector. An angle bisector, you've heard this word before. What does an angle bisector do? Splits an angle in half. So you see here, you've got the angle bisector, and it's cutting these top angles in half. I'm doing my best to mark them, but you can hopefully see that. So cuts angle in half. The main thing here is we're dealing with similarity, so it's going to give you stuff that's proportional. So you can do, let's see, highlight again. I'll write the proportion first, actually. The bisector, so QS over UW is equal to QP over UT. So here's a piece, that's this first one. And then we'll do the next one purple. So like QP for UT. Not that you always have to use those sides because you don't, but just like if you have an angle bisector, it's going to give you proportional pieces. And then the last one is median. Median is not something we've talked about a lot. And median connects to the midpoint. So this is a midpoint. Connects to the midpoint, and you can see that it gives you congruent pieces here at the bottom. So, because that's what midpoints do, is it cuts those bottom sides in half. So again, you have some ratios. You can say HJ over LN is equal to HG over LK. I'll highlight those. Basically, if you have any of these things, if you have an altitude, an angle bisector, or a median, it's going to create, like, cut the triangles in some form or fashion. It's going to make them be proportional and similar, okay? So then, that's this one, this one. Doesn't have to be those exact ratios every single time, but we're noting, like, it gives you similar stuff. Okay, so let's look at this one, and you look at the pictures for me. What is causing these pieces to be similar? What kind of thing do you have on number 12? That line that's cutting, what kind of line is it? It's a median, because these are midpoints noted by the congruent pieces. So this is caused by a median. Okay, so you should recognize when I see a median. A median's when I have a midpoint, cuts it into congruent pieces on each side. This is caused by median. You're gonna set up the proportional pieces. Okay, so let's go ahead and do it. X corresponds to maybe 15. I'm gonna do this actually in like blue or something. Yeah, X to 15. Okay, make sure you keep the same order. So you started with that triangle on the left, you gotta start with it again. If I now choose a side that makes sense here, does it say which one to solve for? No, so you just get to pick one. Let's see, if I choose 16, be careful which side goes with 16. It would have to be the 20 on the other triangle because, okay, 19.2 is the bigger side, so, and it's just been turned. So 16 over 20. Okay, can you do some cross multiplying and solving, please? Yep. Okay. If you're struggling with the cross multiplication, that's because of this. 20x is equal to 240. You solve, you get 12. Okay. Let's move on to the next one. Again, pay attention what kind of, a line cuts down, right, from the top vertex angle. My question is, what kind of line is it based on what you see marked? Altitude, because again, what you're looking at is it drops down and it creates a right angle. It's perpendicular, so this is an altitude, meaning a height. It's the height of the triangle, okay? Altitude is a fancy way of saying height. So this is caused by an altitude. Not that that super matters. What really matters is can you set out the proportion, right? So we can start with x again. X corresponds to 14. And that's equal to, I have to start with 10. And 10 corresponds to 8. Okay, cross multiply and solve. So it'd be 8x equals 140. You divide by 8. 17.5. So you just need to make sure you're putting the corresponding pieces together, okay? And you should be able to tell me, okay, what kind of line is causing this here. Well, in this case, it was an altitude. I don't think I highlighted that one. This one should be purple. There we go. Okay, talk to your table about number 14. What's causing number 14? Okay, this is an angle bisector. In case you're wondering, yes, I will ask you on your test what kind of line is happening here. Or not line, it's rather a segment. What kind of segment is causing this to happen? You should be able to tell me. So that vocab is important enough to learn it, okay? Angle bisector, yeah, because you've got the line cutting through and it gets you congruent angles at the top. You see that the angles have been marked congruent. Okay, get your stuff. You can start with x if you want. X corresponds to 38. And if you started with x and you have to go back and start with that little triangle again, so 24 over the other angle bisector of 32. Okay, those are side equal to each other. Cross multiply and solve. Yeah, because you get this equation, 32x equals 912. Woof. Okay, and it gets you 28.5. Let's look at number 15. Be careful. So you've got the dotted lines. That is not part of the triangle, just to be clear. What kind of line is that? This is an altitude. The altitude is outside the triangle because altitudes have to be perpendicular, okay? So this is still an altitude. And again, you know it because that's the height. That makes sense, hopefully. It's the height of the triangle. And now you can go ahead and set it up. I already highlighted that. So I'll do 12 over 15 first. And x corresponds to 42. Okay. Just want to make sure we talk about that one because the altitude looks a little bit different. It's dropped out to the side to be perpendicular. So we get this fun equation. 15x equals 504. You divide by 15, you get 33.6. Okay, and then the last one here, number 16. What kind of line is causing this to happen on number 16? Okay, you need to look at the congruent markings. The congruent markings are on the side, which means that M and X are midpoints, which means that it's a median. A median connects to a midpoint. So this is median. We're going to do, you can do the medians first. If I do 20 over 12, then that's equal to, okay, 2x minus 9 over x minus 2. Remember, this is one of the ones where you have to be careful. Because these have two terms, you need to make sure that they get put in parentheses when you do your little cross multiplication, okay? So try and see if you can do it yourself. I'll do it on the board all the way out this time. So it'll be 20 times x minus 2, and 12, 2x minus 9. You do have to do some distributing, and then you solve. Gross, what is that? That's 17. Let's get this up. I did, when I moved my variables to one side, I kind of did that in one step. I subtracted the 24x over. So if you did it in 2 steps, that's fine. And then I also added the 40 to the right, just so you, if you need my steps. Tyron. Okay, last thing today, angle bisectors also cut the outside pieces into proportional pieces. So I will highlight for you in just a second, but I gotta write the ratio first for my own brain. This says, so AD over DC, so AD DC. This piece to that piece is equal to AB over BC. So not only can you deal with, so this is like within one triangle, that's the difference. On the last stuff, we were dealing with it within 2 triangles. This is not. This is within one, AB over BC. Kind of like the parallel stuff that we did the other day. So if I have an angle bisector, because I have the angles marked at the top, remember? Then I know that the, how does it say here? The opposite sides, how do we say this? In a triangle separates the opposite sides into 2 segments that are proportional to the lengths of the 2 other sides. I think you can see it. Okay, we're gonna do some examples. Just a few. Probably not even all of these. Okay. Look at number 17, we'll do an easy one first. She's making sure the corresponding pieces go together. It divides us into proportional triangles. It says if KM represents an angle bisector, so you were told that. So you can set up X goes with 54. And you also know that if I do X, then which number do I have to start with? 36. 36 and 40. Yeah, that order matters. That's the biggest thing that I see students getting incorrect. So solve that really quick, and then I think we'll just do one more. So you get this equation, 40x equals, wow, 1,944. You divide by 40, x is exactly 48.6. Okay, we are probably not gonna do number 19. Because I think number 18 is more difficult. Okay, number 18. There was some kind of like this on Delta Math for the word problems. Go zoom in. Okay, when you're doing this, you have to have the outside pieces, outside to outside pieces, or these sides. I don't know how to say it. Those pieces, the one in blue, to these two. And as you can see right now, you only have one of the purple pieces. If this whole side is x, and we know that that little piece is 12, then how can I represent that guy? Or how would I get it? Whole side minus the little piece, what would it be? X minus 12. Take the whole side and you subtract the piece next to it. So now you should be able to set that up just fine. It is, you choose your proportion. Can you set up your proportion however you would like? There's not one right way to do it. And see if you get the final answer of 32. Okay, try it. Make sure you distribute to the x minus 12 because this is in two terms.